Alright, this is a quick tutorial video on how to create a ramp in Google Sketchup. So the first thing that I'm going to do is zoom in a little bit, and I need to get some parameters set. Just to give an overview of what we're going to be doing is we're going to create a two-dimensional object and then pull that two-dimensional into into the z-axis, so into the third dimension. The first thing that I'll do is I'll actually give myself the top of the ramp. And in the bottom right of the screen, if you see, right now it's 294 by 1035. So that's 294 millimeters wide by 1035 millimeters tall. I don't need it to be that big, so what I will do is, let's say we're going to make it, and this is where the hard part is in trying to find the right parameters. But what I can do is I can actually type it in. So right now my hands are not on the keyboard, and what I can do is I can type in, I'll say 100, let's say 25 millimeters wide and 150 millimeters tall. So 2.5 centimeters and 15 centimeters tall. Looks pretty tiny until we zoom in, and then with this button here, I can rotate around, zoom out a little bit, and I'll pan over just to make it easier for me to get this all into full view and make it the way that I want. So from here, I've got this right here is going to be my starting point. This is where the ball or the object or whatever the ramp is going to be sending down. This is where it's going to start. Next up, I'll give myself some distance. So once again, down in the bottom right, it's giving me some dimensions. I don't need to worry too much about those, because what I'm going to do is I'm actually going to change them. So this will be 70 millimeters wide by, let's go 20 millimeters off the ground. Okay. So if you imagine this, ball is going to start up here, or the object, and it's going to come down here and get launched out. Now I want to make this a little bit more interesting, so what I'm going to do is I'm actually going to give it a little bit more of a lip. So it's going to have a 5 millimeter lip. Actually, let's make it a 10 millimeter lip and 5 millimeters wide. Okay. So coming up, it is 5 millimeters, and going wide, it is 10 millimeters. So I'll go over what that may look like. Next up, we need to give it some arc. So here's a cool piece about this is I can actually take and go from an endpoint to an endpoint. So I've clicked once, clicked twice, and now I can give some sort of depth. Although if I look at it, not really doing what I want it to do. So let me come to these corners. And if you notice here, it doesn't give you exactly what you're looking for, but we can try it out. So just to check and make sure that this is still on the same plane, I'm going to rotate around. Yep, nice and flat. And the next thing that I want to do is I want to actually give it some sort of the ability to launch. So in this case, let's start from the endpoint and go to this bottom corner. And we'll go here. And then now we're going to go from this intersection to this top lip. Not going to be perfect, but it will give us something to launch from. So as of right now, the way that it's designed, the ball is going to come down here. It's going to hit this completely parallel to the ground object, and it's probably going to clunk and stop here. We don't want that. What we do want is we want to get rid of some things. So I'm just selecting and deleting out all of the unwanted segments. And now look what happens. So I've got the object that starts up top, runs down, and actually comes to some sort of angle that hopefully the students would measure, and object gets launched. Now from here, the reason that we're going to do this here is so that it actually slows down. You don't want it to just have a downward progression, because then you're going to be using up quite a bit of floor space. If you're doing this project to see how many times they can get it the closest to the wall, this would allow you to try to do things within an 8 to 10 foot range instead of having it go across the entire classroom. Also would limit the amount of time that it would need in order to be a productive day. So the next thing that I'm going to do here is I'm just selecting and deleting off all of the extra segments inside the ramp. So this is what it should look like. And I would strongly encourage that this is not the exact same model that you use. It's just an example. So next up, what I'm going to do is I'm actually going to push or pull. Well, in this case, I'm going to pull. So I've selected this here. I'll click once and lift up. And a distance that is safe depends on the ball that you're using. You may say 1 centimeter if you're going to be using a very small ball. In this case, I'll say that it's going to be 15 millimeters. And you could type in 15 and get something perfect, but in this case, it ended up working out pretty well. Now, very cool stuff. This is done. The problem is that it's going to take up a lot of ABS or whatever type of material that you're using, and a lot of it's wasted. It's unnecessary. All of the content inside here is unnecessary. So what we're going to do is we're actually going to, so I just Control Z, undid that. What I'm going to do is I'm going to actually clear out some of the unnecessary pieces. Here, and just click on it and delete, click on it and delete. So now it looks kind of like a shoe, but what this does is it allows me to conserve some of that plastic and speed up printing time. So now I've cut out a pretty large chunk. I could get a little bit more, but in this case I'm not going to. Something else to note is the angles in which things are printed. So when you actually put this into matter control, you're going to be rotating it 90 degrees across the axis so that it can be vertical and printed out easily. The problem with that is that if you don't have a good enough angle, the printer is going to mess up. For example, if I were to print out this piece here, it's going to have a hard time because there's nothing for this layer to build on from this layer here and this layer here and so on. So it's going to sag a lot. You're going to get a lot of extras that you don't necessarily want. It's not going to look very appealing. Whereas this piece here, it's at a 45 or about a 45 degree angle, and it has enough on the layer below it that will build and mold with the layer above it. So just keep that in mind as you're designing it and as your students are designing it as well. Now, let me go back to the push-pull. I'll pull up and 15 millimeters, and this is now finished. If you wanted to modify this for your students, what you could do is you could give them a template, something like this, or something a little bit more challenging, depending on the level of students that you're working with, but providing it to them so that they have something to build off of, and then they can go in and they can actually create something from that. If you're going to do that, what I would encourage you to do is start with a two-dimensional model and simply show them how to pull once they get their completed 2D model. So hopefully this helps. Good luck.